In this video, we're going to consider the regret criterion with uncertain inputs. So let's look up here at this matrix that has our raw input data. These are the values that you saw last time when they were point estimates. This time we're saying if we use recruitment strategy 1 and the economy is strong, we're not exactly sure how many students we'll get. So you can see that embedded in here we have a triangular distribution where strategy 1 might bring 120 students all the way up to 140 students with a most likely number of 130 students. The input is uncertain. And each of the inputs in this model is similarly embedded with a triangular distribution. And that would reflect the uncertainty in our analysis. So let's take a look at these data. I'm going to turn the simulation on and I'm going to hit the F9 button, and you'll see the number of students who are successfully recruited by each strategy under different economic conditions changes. The rest of the model is familiar. For the strong economy, we calculate the regret. And you can see here the numbers associated with these outcomes. We do the same thing for the normal economy and the weak economy, and we transfer these numbers into our regret matrix. So now we have a regret matrix that varies, and it's varying because there's uncertainty in the inputs, those being the number of students recruited under different strategies and economic conditions. Here we have the maximum regret calculated from the matrix, and as before, we choose to minimize the maximum regret. This cell identifies the strategy that is best for this particular scenario. So what we're going to do is focus on that for a moment. You see sometimes it's 2, sometimes it's 3. So we're going to run a simulation of 10,000 iterations. And even though this is a small model, it takes a little while to initialize because there are a great many if-then statements embedded in it. And soon we'll see the results. And in this particular scenario, we'll see a minimum of 1 was obtained. So strategy 1 is sometimes optimum. A maximum of 3 was obtained. That means strategy 4 was never optimum. And here we see strategy 2 is optimum, about, what is that, maybe 62% of the time. Strategy 3 is optimum, maybe about, maybe 37% of the time. And maybe this is another percent or so of the time when strategy 1 is optimum. So what we have here is the ability to deal with uncertainty using the regret matrix.